Hello. So continuing on with the Python tutorial, we're going to talk about loops. So for loops and while loops. Now, loops are essential in Python, and they essentially allow programming to be superhuman. Otherwise, if we didn't have loops, a lot of this stuff would be irrelevant. We could all do this easily by hand. So first, let's make a new project before we jump into anything. Right click here, new Python file. Let's call this loops. Cool, we're there. Okay, so I want to start off with an example. Let's say you want to build a for loop to work out your monthly expenses. So let's say you've got bills, and I want to store that as a list, and then each one of these bills corresponds to let's say a month. So say £100 for 1 month, £200 for the next month, £150 for the other, and 200 again. I just make it more unique, 300. Obviously it's not realistic to have those sort of bills, but a programming sake, let's stick with them. So without doing a loop, the most common way if you wanted to add them all up would be doing something like 0 plus bills of one index plus bills of the second index plus blah, 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 blah. You get the idea, right? Let's just stick up to 2 right now. So yeah, I'm not adding all the figures because you get what I mean. I just think it will waste a lot of time. And then we'll just put the total. Yeah? But that is quite finicky, because what would inevitably happen is if the list became incredibly large, like there's thousands or tens of thousands of list values, you can't add them all up by hand. That's tedious and stupid. So programming has obviously come up with an answer. So something along the lines of this, where you say for, and then you have to give a variable name. So let's say item in bills item. So what's actually happening is this for loop is basically, or this line is saying, get this list of bills, get each item of the bill, and one by one pass that item in the bills to item as a variable. So in this case, the first item will be populated, and that item will be passed to the variable item, which is shown here. So if we just print this out, and delete this total line, if we just run this, you can see it printed out the values we wanted. So just to go into one helpful thing I do when I'm trying to debug something is I make a print statement saying stop. So what that allows me to do is it allows me just to stop before the execution of the code all finishes. It's quite helpful. So yeah, let's debug this. So right click, debug loops. So you can see here we're in this line, and then if we go into this loop, you can see the item is assigned the first value in this list. So it usually has the same order, so the first value in the list will be assigned to item. And then you can see it kind of goes through all the different versions. Yeah. So to get back to the point we were trying to do, we were trying to add up all our bills. So we could say item, let's make a variable here, an empty one. So this will be our whole variable. And we can say total equals total, so obviously it's self, and then we're going to plus on the new item. So this basically says, since our total value is 0, get whatever that value is currently, add it with the new value, and then assign it or overwrite it to total. And so when the next loop happens, the new value will be assigned here. So that's how you add up or append values to a total variable. So we print this now, total, and we run this. Let's just run it without debugging it. So you can see 750. And then Yeah, so you see how that works. So it all adds up, all the values into total, and in the end we just print it out. Simple stuff. Okay, so another way you can use for loops is with a range function. So let's comment this out first. You can comment with control /, but my computer doesn't seem to work with that right now, so I want to use that. So let's say you wanted to use the range function. So what that does is it just specifies a range of numbers between your entry and your exit, whether you specify them or not. So let's say I, in this case, is our temporary variable, in range, and range, let's see if it gives us a helpful hint. Oh, it does, okay. So we can specify a start value, so let's say we want to start at 1, and then we can specify a stop value, so let's say 10. And just bear in mind that the stop value, it should be 1 plus what you want. So let's say we got 1 to 10. That means you'll have 1 minus 10, so 9. And if you want it to count 10 as well, then you'd have to do 1 plus, so it'll be 11. So that way you're doing 10 values from 1 to 10, because the range stops on that value. So if you had something like 10, it would do 1 below that, which is just worth bearing in mind. So if we print out I, so let's run this. So you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Now if we made that to 10, you can see how it misses out the 10, because it's more like a checker. So when it goes down, it goes up and then checks its I value with this value, and then if they both equal one another, then it says, okay, we've done enough, stop. So it's just worth bearing in mind. So this is pretty useful if you want to make if you want something to loop a certain number of times and you don't have a real dynamic requirement. So another way you can use range is with specifying list lengths. So let's say, for example, as above, we have this thing here. So let's comment that out. So you can see how we got build, we got 1, 2, 3, 4 items. Now what we can do, let's comment that out. What we can do is something like this. We can say for I in range, and then we can say len build. So what this does is it provides us with an index value of builds. So the way to think about it is, let's see if we can get a Python console. Yeah, so let's say we have builds. Control C that, Control V, enter. So let's say we have builds, and we know that we have index values assigned to them from the index tutorial, or from the list tutorial I made. So we know that these indices can be used to grab certain values from this list. So what we're doing here is we're getting the list, we're then getting its size. So we know that the size of builds is 1, 2, 3, 4. And so it's returning us a value of 4 and saying for I in range of 4. Now that then gives us index values, or it gives us the number range between 0 and 3. So remember how in the list tutorial we said that the first item would be 0, the second item would be 1, 2, 3. So this prints out 0, 1, 2, 3. So if we try this then, you see how it prints out 0, 1, 2, 3? So these are index values that we can use for our particular code. So then we can say something like print And if we run this, it kind of gives the same effect as what we did previously with this. Well, ignoring the part where we added them together, but if you just said print items, it kind of has the same effect. But this does give us more control because we have actual control of the indices. So it's useful when working with lists, and when we do go into more complex topics, this will become more useful. But let's just make an example from this. So we know that the I is equal to the index value, and we know that each one of these index values is equivalent to a month, right? So we'll know that this is the first month of bills, this is the second month of bills, this is the third and the fourth. So let's just use that and manipulate our data to show it in a more readable way. So let's say bill for this for month, let's say I, let's say the cost is and let's run that. So we're saying the bill for month 0, or maybe we should add 1 to that. That makes more sense, because obviously you can't have a 0 month, right? It's always the first month, or the second month, the third month, the fourth month. So what we're saying is, for the first month, this one, which is index value 0, we're getting this much as the cost. And for the second month, this much as the cost. Third month, fourth month, you get the idea. Okay, another simple one we could do is to do, or at least finding, let's try finding a string in a list. So let's say we have a list. Yeah, so let's say we have a list, something like words. And we're playing some interesting game where you have to find a word in a list of words. So let's say thing, pop, poo, because why not, and p. Somehow I can only think of really silly words. So let's try this. So let's say we have a key, and we want to find the word pop. So let's assume there's thousands of words in our words variable. How would we go about doing that? So what we can say is something like for word in words, our variable, and we can say if our key here, so pop, is equal to our well, if key is equal to word, then print found with, yeah. So one issue with this, obviously, is you can't find the index value, right? Because as you're just looping through, there's no way of keeping track of the index value. And so that's where the for loop with the range feature, where you find the length of the variable or the list, is a much easier way of doing these types of searches. Now obviously this will work, but it won't specify where the position is, where it's found. It just says, okay, it's found, we know it's there. And yeah, so another variation of this code could be something like this. Now the continue keyword is quite useful here. If this condition is met, so we're saying if the key pop is not equal to the word, then we skip this current iteration and go back into a new iteration. It's pretty useful. So yeah, so let's say you have certain logic below this that has to be implemented only if the first statement is satisfied. Okay, so finally let's go on to while loops. So while loops are pretty much similar to for loops, but they're a bit more of a skeleton, let's say. There's not much meat on it, if that makes sense. So let's say I equals 0, And let's say while I is smaller than 10, I want I to add equals I plus 1, and I want to print I. So we're saying here I is equal to 0. As long as I is smaller than 10, keep this going. I equals I plus 1, so we're going to have I equal 1, 2, 3, 4, 5, 6, 7, 8, 9. And as soon as it becomes 10, this clause will become null and it will exit the loop. So if we run it, you can see it goes up to 10. It went up to 10 and then stopped on 10. Because it probably went to here and said 9 is smaller than 10, then added on 1, so it became 10, printed out as 10, and then we said 10 is bigger, 10 is not smaller than 10, so that clause then became false. Yeah. So if you get rid of the logic here, sometimes you can have infinite loops. So for example, if you just stated this as being true, and we ran it, you can see how we just kind of have an infinite loop and we keep going. Right, we had a pretty big number. Yeah. Another thing we can do is something like break statements. So this is both valid for, so the continue statement is both valid for while loops and for loops, and the break statement is also valid in while loops and for loops. So we can say if I equals, let's say 5, then I want you to break. So break just means exit the while loop or exit the for loop completely and move on to the next section of code. So if we run it like this, you'll only see, I guess you'll see only 0 to 4. So you see? 1, 2, 3, 4. Because we came through, we're adding 1 each time, and then the clause came here, it went on to 5, and then we broke. So let's just put this into a debug statement. Try that again. Yeah. So we come in as 1, that clause does not meet. And then we hit the break because our I is equal to 5, and we exit out. Okay, so that covers loops in general, and I think that's most of the stuff that you'll probably come across. Yeah, I'll end the tutorial here, and I'll catch you in the next one. Bye bye.